right? Trace of the product. I have to take the sum of the diagonal entries of AB. Now I know that AB, if I take the ith entry of AB, what's that? That's going to be the sum. Now remember, the first index on A is the first index in the product, and the second index on the B is the second index in the product. So we get this sum from k equals 1 to n. But now I'm summing over all the diagonal entries, so I have to sum that from I equals 1 to n. So that's where this expression comes from. Sum I equal 1 to n of the sum from k equals 1 to n. Now, just for jollies, let's consider the trace of AB, trace of BA. And you'll find that you, in fact, get the same, well, let's do this. You get something like this. Now, we've done exchange of summations before. And in this case, because the limits don't depend on the indices, we can simply exchange the summations. And we can also exchange the entries within the product, because this is just a product of ordinary real numbers. And we can rewrite this trace, exchanging first the summation, and then changing the order. Well, all right, first changing the order and then changing the summation. We find out that we end up with something here that looks very much like what we had here. The only difference is that the I and K are exchanged. But I and K are just letters to indicate an index. So I could replace these I's, all these I's with K's, and all these K's with I's. So if I take this and I exchange K with I, which won't change anything because those are just indices, if I exchange K's and I's, I will end up with this term here. So what's the point? We've shown that the trace of AB is equal to the trace of BA. All right, so we have some exercises with traces. And that's the end of this section.